Good morning students, welcome to the class of Mathematics. So today we will see how to solve a problem where the concept of inertial frame and non-inertial frame is involved. That is, when a body is hanging in a lift in a certain space which is not on earth, right? That is hanging to some separate reference, right? So we will have the concept of inertial and non-inertial frame over here. So in all those questions, we will use the concept of non-inertial frame, right? Here in the lift, the mass is hanging with a spring balance. We need to understand what is the weight read by the spring balance, right? So here, the inertial frame is a frame of reference where the applicable law of forces are valid, right? That means whenever you are seeing standing on the ground from outside world, from the earth, that the forces or whatever the activity which is happening, that is from the reference of inertial frame. But if all those hanging mass or all the applicable forces which are shifted inside a lift or inside a closed body which is not directly impacted with the earth movement, right? So that in that reference we will use the non inertial frame of reference, right? So here the lift is going with an acceleration of z by 2 downward, right? So here we need to understand that in any case where the non-inertial frame of reference is involved, we always use a pseudo force, right? What is that pseudo force? Pseudo force is is an additional force which will be reduced from the given applicable forces with reference to the inertial one, right? That is the additional force in non-inertial frame which will be inserted or added for a non-inertial frame, right? Right. So here the mass is hanging in the lift from a window and the lift is going with a acceleration of z by 2, right? So let us draw the free body diagram of the mass m, right? Here the mass m is of 2 kg, right? So the applicable weight over here downward will be mg, right? That is in the inertial frame of reference. We will do all the components, we will add all the components of the forces as per the inertial frame of reference plus pseudo force, right? And here T is the tension in the spring balance, that is that will give the count of the spring balance, that what it will read for the mass of 2 kg, right? And this m into z by 2, that is in reverse to the acceleration of the lift, in reverse to the direction of the lift, that is the pseudo force, right? This is the pseudo force which will be applicable over here in all such questions of lift, right? So this is the pseudo force which will be reduced from the in reference to the inertial frame. That means this will be acting in a negative direction. That is, it will be acting towards opposite to the movement of lift. That's why I am showing it upward. Now, as per the free body diagram of the mass, T and M A, that is M into Z by 2, will be acting upward, and this will be equal to the total force acting downward, which will be mg, right? This I am again mentioning that m into z by 2, that is m into a, is an additional force which is acting in a reverse direction, right? That's why I have shown it upward, and this is the pseudo force. We also call it as inertial force or inertial force, which will be additional to the existing force of existing force in non-inertial frame with respect to inertial frame, right? So with this one we have write the free body diagram, and the equation we have arrived at T plus mg by 2 equal to mg, and we know the value of m as 2 kg. So putting over here m equal to 2 kg, so 2 into z by 2 equal to 2 into z. Here in the LHS, 2 and 2 will be cancelled in the numerator and denominator, and we are left in the LHS with t equal to 2z, and z from LHS we go to the RHS, and 2z will minus z will be into the RHS. So T is the tension which is read in the spring balance, that count is Z, right? 2Z minus Z equal to Z. G, that is 1G, right? We can write it as 1G, and which is equal to 1 kg. G is the acceleration due to gravity. So 1 kilogram is the mass which is read by the spring balance hanging in the inside the lift, right? So we have the question that what is the reading of the 2 kg mass when it is hanging in a lift with a spring balance. So the spring balance, we can say it will read as 1 kg for the hanging mass of 2 kg, right? So in this way we have solved these questions. So the spring balance in the lift will read 1 kg for the given 2 kg of mass, right? For the given 2 kg of mass. So I am writing here in the red color 1 kg, right? This is our answer, right? Thanks, like and subscribe to my channel and keep on learning. Bye.